Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I catch up with Adrian Brink, one of the founders of Anoma. Anoma is a new protocol for multi-asset privacy and end-party bartering. We chat about his previous work in the space and then dive into the new project. We talk about their aim to create a system that allows any digital asset to function as a means of exchange or payment, and what kind of projects or ideas Anoma could enable. Before we start in, I want to let you know about the next upcoming zkSessions event. Event happens on June 23rd, and the topic will be all about DAOs, NFTs, and novel funding mechanisms. One of the goals is to find out if and how we may be able to incorporate privacy and ZK ideas into these new systems. I will also be hosting an interactive community discussion about how the ZK community could potentially start using some of these tools. Event happens, as mentioned, on June 23rd. I've added the link in the show notes, and I hope to see you there. Next up, I want to thank this week's sponsor, EY Blockchain. EY is committed to building a better working world on the public Ethereum blockchain with robust privacy technologies like zero-knowledge proofs. EY believes blockchain technology will be the glue that knits together a productive global business ecosystem. To learn more about their products and services, visit them at blockchain.ey.com or check out EY's open source contributions at github.com/EYBlockchain. I've added both links in the show notes. So thank you again, EY, for sponsoring the Zero Knowledge podcast. Now here is my interview with Adrian. So today, I am talking with Adrian Brink, one of the founders of Anoma, which is a new protocol for multi-asset privacy and end-party bartering. Welcome to the show, Adrian.
Well, thank you for having me.
So Adrian, you've been in the space for a while. I think we've known each other for at least 3 years. But at the same time, this is actually the first time I have you on the show, I believe.
That's true, yes.
So before we start in on Anoma, let's do a little background on you. Where did you start in blockchain? I think we met at the first ZK Summit, the first back in 2018. So you're clearly there already. Yeah, tell us where you started.
So I wrote my graduate thesis in computer science on e-voting on blockchains. And this was at the time of the Catalan independence referendum. And I'm personally not a huge fan of independence movements. But I thought it'd be neat if the Catalan people can have a way to have censorship-resistant e-voting systems. And I built it on Ethereum at the time. And of course, any computer scientist listening right now will know e-voting is the thing that no one wants to touch in computer science because everyone believes it's completely insecure. For some reason, we put the financial system on computers, but no one trusts it enough to put voting systems on computers. Still funny to me. But yeah, so I built this. And as part of the background research, I came across Tenement Consensus, actually, dove into this. And then I ended up joining Cosmos as the third core protocol engineer, mostly because I had written Jay that I know how to code and whether he needs any help building it, because I thought it was a neat project.
It was early. What year are we talking?
This must have been 2017, I think.
Okay. Was the project already launched?
No, this was just about the time of the fundraiser. I think I joined a week after the fundraiser. From there, built up the entire Cosmos stack, helped out there a lot. Afterwards, we launched Decryption Labs as a validator. We were one of the very first validators, and this is also where I know my two current founders from Awa and Chris, because we were all working in Cosmos at the time. So we built up Decryption Labs as our answer to no one knows how to run these things. No one knows how to run proof of stake. And the people that build it are clearly the most qualified to also run it in practice. So we sold that company earlier this year to Chorus One. Mm-hmm. But also it turns out that validation is honestly not that interesting on the long run because it's mostly racking up servers and data centers. And we always loved doing research and protocol engineering. So we ended up for probably a good 2 years being the second core dev team on Tezos, shipping all major upgrades while we were there. So we scaled this to 15 people and we took everyone with us to work on Anoma, which we launched earlier this year.
You mentioned your two co-founders, Awa and Chris. Awa has been on the show, I think once during a combo episode, which I did in an event. So a really short interview. And Chris definitely was on the show last year talking about IBC.
Yeah, Chris is the lead author around the IBC protocol. Also worked on Tenement consensus for a long time and Cosmos Proof of Stake system.
Was it the three of you at Cryptium or just you and Awa at Cryptium?
No, it was just three of us as well.
Oh, it was. Okay. So this is a long-standing founding team.
Yeah, no, we've built, at this point, 3 companies.
I should also, as an aside, say the Zero Knowledge Validator is actually an investor in Anoma. But when we did that investment, we were kind of an early stage investor. You know, I know since then there's been quite a bit of development, and that's what I hope to jump into today with you. So let's dive into this new protocol for multi-asset privacy. What, in a nutshell, is Anoma?
So in a nutshell, Anoma is a protocol fundamentally designed differently than the existing smart contract platforms like Ethereum, and also the existing chains like Ethereum, like Bitcoin, for example. Anoma is fundamentally asset agnostic. It doesn't care. It doesn't have a specific base layer asset. Of course, there's a proof of stake asset, but you can, for example, pay transaction fees also in other assets that you bring onto the platform. So Anoma fundamentally makes the choice that the world is going to be interoperable. We don't know necessarily via which protocols, although we have good ideas there, but assets will flow free of state machines, and Anoma is there to enable people to have multi-asset privacy for whatever assets they want to bring, and to allow them to be traded in a very flexible manner, which is derived from a protocol called the Wyvern DEX protocol, which is backing the protocol behind OpenSea, by the way. No one knows about the protocol because it doesn't have a token. Chris wrote this a long time ago.
What's the name again? Can you say that?
The Wyvern DEX protocol.
Wyvern DEX protocol.
Wyvern, yeah.
Wyvern DEX. Okay, cool. We'll put that in the show notes for interested listeners then.
Yeah, and also architecturally, just Anoma makes quite a few different choices. So it's built around fast finality BFT. It uses fractal scaling. Like, we don't believe that there needs to be one validator set that rules all state machines. I think this is very, very unlikely to appear in practice anyway. It seems very unlikely that we move world commerce into the Ethereum validator set, no matter how scalable it is on a technical side. It's just not how humans socially work. We don't have a one world government for the same reason. So Anoma scales fractally, that there can be many different instances in different geographies run by different people, but they all interoperate with each other. And assets can flow within Anoma as well as from Anoma to other systems and into Anoma. And you can just use these assets to privately pay someone, to just shield your assets, to make your own assets without transferring them private. And it also allows you to have these very complex state transitions where, for example, you want to trade a CryptoKitty for a concert ticket in Barcelona, for some BTC, for some ETH, and in Anoma you can atomically settle all of them. And I think maybe the last thing here is also that we fundamentally believe that zero-knowledge proofs are going to be big, and privacy is a fundamental human right. So what people can do actually is deploy their own validity predicates. And those validity predicates can do a lot of things. They can be, they can be like, for example, a new private bartering circuit, a new private trading circuit, a new privacy-preserving transfer protocol. But developers can write these, and we're building a language called Juvix, which compiles down to zero-knowledge proofs, which makes this very convenient. So developers can deploy their own validity predicates as well.
There's so much to go into in everything you just said.
I'm sorry about that.
Let's take one thing that stood out to me here was the fractal scaling. This idea of various ecosystems, various blockchains. This sounds a lot like the Cosmos ideal and this concept of like IBC. And I know Chris worked on that. So I'm wondering, like, what is the connection in your mind between like the way you're thinking about this fractal scaling and what you were working on at Cosmos and what Chris was working on at IBC?
Yeah, so I mean, Chris is the lead architect on the IBC protocol, and IBC is a fantastic protocol, I have to say. I think people don't really understand this, but IBC isn't tied to Cosmos. IBC will work between Near and Polkadot.
Yeah.
And Anoma and Near. It's just like
it's a bridging idea, right? Isn't it? Isn't it sort of like a form of a bridge?
It's not a bridge in itself. It's just a way to describe how data gets transferred proof-carrying data gets transferred between two blockchains, and how it gets authenticated. You can think of this more like TCP/IP, where it's just the protocol that describes how a packet from Polkadot that's authenticated with the Polkadot validator set can be read and interpreted on the near side and vice versa.
It doesn't involve creating light clients on each of the chains?
So that is a requirement for the protocol, that you have efficient light clients.
Okay, you do have light clients.
Yes. So that's a requirement in order to be able to instantiate the protocol. You need to have efficient light clients on either side, because otherwise the communication complexity blows up. But yeah, so Anoma doesn't take the view that Anoma isn't a routing hub for assets. Anoma is just a protocol where people can use their assets initially very much for privacy reasons. So for multi-asset privacy, Anoma will be the very first solution, I think, in the world where you can have a unified privacy set between all assets, right? When you think about things like Zcash and Monero, the reason why they have a really hard time getting traction is because while they provide privacy, they tie it into like a very specific asset. And like, I don't want to pay for coffee in ZEC or Monero tokens.
Although apparently there are places that are accepting that.
Yes, but I think this is sort of this like weird thing where like Room 77 in Berlin was accepting Bitcoin for burgers. It's like a weird novelty, but it's not going to be the thing that gains traction. So with Anoma, you get for the first time multi-asset privacy, where to an external observer, it's indistinguishable whether you are buying coffee using USDT or selling a house for $100 million. So all assets have the same privacy guarantees. And you can sort of think of the multi-asset shield pool, which does this as an extension to Sapling, right? Where Sapling shields sender, recipient, and amount. The multi-asset pool also shields asset identifier.
Like, is there actual computational stuff? Is it more than just transactions that are happening in this privacy setting? What I mean is, like, is there private computation? Is there some sort of, like, more than just account balance changes? Is there something else?
The multi-asset shield pool is just one specific validity predicate in Anoma. Okay. So there can be many more. You can deploy others that do more private computation, but the multi-asset shield pool specifically doesn't do private computation. It just does proof checking that account balances, that like you aren't inflating tokens.
Let's talk a little bit about its connection to Sapling, because you're using part of Sapling in your construction of this, right?
Yes, so this is an extension of Sapling. The Sapling is great. There's no reason to throw away Sapling. I don't understand why a lot of the privacy tech that tries to do this on Ethereum doesn't do this. But like Sapling has amazing features like viewing keys and spending keys and so on. So I'm a big fan of Sapling. So this is an extension to Sapling.
Got it. But did you redeploy it then? Like, or is the idea that you're going to take that code and redo it? You're not actually connecting to the existing live Sapling on Zcash.
Oh, no, not at all. We're just using the code, and the code is being redeployed. So the extended code, the multi-asset shield pool, is being redeployed. This also means that we have to do a new trusted setup, which we're going to start sometime this summer. Depending on where the research goes, we also may do like a Plonk P lookup, trusted setup at the same time, so that we get a universal proof string. So because one of the ideas behind Anoma is that people are able to write their own zero-knowledge circuits using Juvix. And it's very inconvenient to deploy a zero-knowledge proof application if you have to redo a trusted setup every time.
Agreed.
So hopefully we can get around this with Plonk P lookup, and then people can just write private applications and deploy them directly.
If anyone wants to learn more about trusted setups, last year I did a series of episodes all about all of the trusted setups that have happened so far. And I think since then, there's at least Plumo, which I actually work on and help out the team with. So that's another trusted setup if ever anyone wants to try one of these out. They're kind of annoying, but also kind of awesome because you're like deep in the tech. You're like actually contributing to real privacy.
Honestly, I think the biggest thing with private setups is mostly that you want a large number of disjoint participants, and that you ideally don't want to have to redo them. So if you can honestly get like an efficient universal trusted setup, that'd be very convenient.
Totally. Let's go into the bartering system. This idea of, I think you hinted at it in the intro to Anoma, but like you talked about different assets. So bartering, that idea of like trading the milk for the flour, like object for object, but with no dollar in between. Tell me a little bit about what that looks like.
Yeah, so this is very hard to build in other imperative kind of systems, like the EVM, for example, because the account model isn't structured the right way. But with Anoma, the way the account model is constructed is that all changes to the state are happening first. So the state changes are applied first, and then all involved accounts simply get the resulting state and can verify whether they're okay with it or not. And then they say yes, no on the state changes, which makes the computation to do state changes to lots and lots of accounts very, very efficient, because you can do all the sort of verification of the state changes in each account fully in parallel.
Okay.
Because they're not dependent on each other, right? Like when you think about this in a traditional system, you have this like step-by-step execution where you sort of go like, well, contract 1 does some execution steps and then calls contract 2 that does some. In Anoma, this all just happens, all state changes first, and then everyone gets called whether they're okay with the resulting state. This allows us to build an incredibly flexible n-party bartering system. And what I mean here with n-party bartering is the example, for example, is let's say Alice has some BTC and wants ETH, Bob has ETH and wants, I don't know, dots, and Charlie has dots and wants BTC. Traditionally, there's no way to settle all three desires at the same time. And we're calling them intents. So there's no way to settle all three intents at the same time. But with Anoma, we can just take all three of them and settle them directly, thereby removing the need to have one liquid pair that everyone connects to, right? Like traditionally, the way this is solved is everyone just like has a liquid pair against USDT. And when you want to do this kind of three-party trade, you all go via USDT to settle this.
I have a question here about prices and like how you define this stuff. Like, are you deeply connected? Like, do you have an oracle? Are you pegging this to something?
Right. So this comes to the way assets flow into Anoma. Anoma fundamentally interoperable. So assets flow via IBC or some other interoperability protocol. It really doesn't actually matter what the interoperability protocol are. So now you have an asset in Anoma. And there you just define at what price, like for your individual intent, you're willing to settle this or to trade it. And then there's a role called matchmaker that looks at all the hundreds of thousands of intents flowing through a system and sees which ones can be combined together and settle on chain.
Is there a base currency then? Is there like a base value that you can peg this to?
No, this is not pegged at all. Like when you think about when I'm submitting my intent, I have BTC and I want ETH. I'm saying I'm willing to trade it at this price or better. And someone else may say they're willing to trade ETH for BTC at this price or better. And then these intents are starting to flow through the system. And a matchmaker will look at them and go like, well, these two are compatible. Let me combine them and settle them on chain.
That's one-to-one though. That's like ETH, BTC, BTC, ETH. But like when you talk about bartering and like including these other assets and you're bundling them, how do you assume the value?
Right. This is why I also like the tagline of undefining money. We don't need this form of base currency. So if you have the intent BTC for ETH, that has some exchange rate effectively attached to it that the user sets. And then you have another intent that says ETH for dots that also has an exchange rate. And a third intent that says dots for BTC. So everyone has their own defined exchange rate effectively at which point they're willing to trade. And so if you see three of them, you don't have to settle them one by one. You can just say, well, settling all three of them at the same time gives everyone what they want at a price that's equal or better than what they said they were willing to take. And the best part here is this doesn't stop at three. This goes to, you can be 1,000 people. You can be trading the most random assets. Like you can be trading local currencies. You can be trading commitments to climate change. You can be trading like CO2 certificates because they don't need to be tied into like underlying base currency. This is an incredibly generalized system that allows people to do business with other people effectively.
I know that like in a previous episode we did with Martin Krüppelmann from Gnosis, we talked about this concept of coincidence of wants because they have this cow protocol. And when I was going through Anoma, I saw that you mentioned you don't follow that model. It's not coincidence of wants that you're using.
No, I don't know how Gnosis uses this, but we just don't rely on the fact that two people have to have exactly the same coincidence of wants. It can be 3 or n people that collectively have an overlapping set of like where they all coincide in terms of what intents they have. Yeah, in traditional market, this is always two-way that you like, if I want to trade a chicken for a cow, I have to find someone that has exactly the inverse. With Anoma, you don't. You can find sort of a group of people that collectively settles everyone's desires.
But what if I wanted to unload a terrible, terrible dog coin and nobody wants it? What happens?
Then you will never get settled. Like if no one ever wants to buy the thing you're selling.
Okay. So like you can put it there, but no one's going to ever take you up on it.
Exactly.
Okay.
Maybe also, like, as a note on the architecture here then. So in Anoma, there are hundreds of millions of intents possibly flowing through a system, but they never get settled on chain. Only those that actually get matched with other intents get settled on chain, which means that, for example, like the way a market maker would operate is they probably quote a new price every half second or so, and they just send them as intents. So they keep updating their latest viable price, and then someone can pick it up and, oh, I like this. I like the price you're currently quoting. I'll settle this on chain.
Do you, like, as sort of a person offering, you're kind of, you want to participate in this, do you offer two things, like what you want and what you're giving? Or do you offer what you're giving and what, like, a selection of things you would accept back?
You can do both. This is completely up to you.
You can.
Because you can think of intents like a function that just says what state transitions you're willing to accept. So you can say, I'm willing to accept 2 tickets for Imagine Dragon concert in Barcelona, or 3 blue CryptoPunks, or a BTC, or a combination of all of them. But it's up to you. So when you write your intent, you write a acceptance functions that says, I am willing to accept, and in the function you just define what you're willing to accept.
Cool.
Which means the cool thing is this goes way beyond trading. It means that you can start having things like we collectively agree to, and only if, let's say, a certain percentage of the network agrees to, with 1% of our transaction fees, commit to sequestering CO2 from the atmosphere, for example. So you can do these very generalized collective commitments, is what we're calling them.
Are those, like, the thing is that, like, taking carbon out of the ecosystem, that would be some, like, I know that there's a protocol that actually does that, I think, in the Cosmos ecosystem where, like...
Oh, region. Yeah, they do it differently, though. They, like, try to map over... Okay. They try to identify who's doing well in terms of environmental damage.
Oh, I see. Okay. Okay, but say there were, though, these, like, credits. You'd still need, like, a second entity to issue those somehow, and those would maybe be NFTs? Like, I'm trying to picture what that example looks like.
Anoma doesn't do asset issuance. I mean, you could if you wanted to, but this is really not what the protocol is good at. Things like Ethereum are great at asset issuance. And Anoma just provides the ability, once you have these assets, to effectively come to agreement over them, to come to agreement with using these assets. Like CO2 sequestering is far away, really, and we need a bunch more infrastructure. More supply chains need to be on blockchains. This data needs to be available. We need better Oracle systems. Yeah.
But it could eventually maybe be in it.
Oh, absolutely. Like, eventually this is the goal. Like, once we put the global economy on hundreds of millions of different blockchains and data can flow freely between them, we can design amazing computation to, like, incentivize the right behaviors for people.
Does it sort of fall into the category of a DEX? Like, do you think of it like in that space, or is it something else?
So if you wanted to think of this very simply in terms of early things that you can do with Anoma at launch, you can, for one, think of this as a mixer, kind of like an interchain mixer almost, because you can get perfect privacy for all connected assets without having to transfer them, right? The multi-asset shield pool also just provides them if you transfer them to yourself. And secondly, you can kind of think of this like a DEX, but not really. Like, the DEX is like the simplest of applications that can be built on Anoma. So, like, you can build a DEX on Anoma, and the protocol supports this fully. But long-term, this is much more than just a DEX. Like, this is a way to come to agreement over arbitrary state transition functions, rather than just like, I want to trade a Bitcoin.
Got it. Is it based on, and maybe you already mentioned this, but is it a proof of stake protocol in itself? Does it have a validator group?
Yes, Anoma's proof of stake.
And it's based on Tendermint, I guess?
So not the proof of stake system. So it uses Tendermint consensus.
Okay.
Albeit we're probably going to swap this after launch at some point, either to Honey Badger or heterogeneous Paxos. But yeah, so it's not built on any of the existing stacks. This is all written from scratch. We just happen to use Tendermint consensus because, honestly, Tendermint is a fantastic consensus algorithm. And I still think it's stupid that everyone is trying to reinvent consensus.
Makes sense.
Like, you're not gaining that much. In 2017, we had a weird time where, like, you could race for new consensus algorithms. It was very strange.
But so you're going to have a validator community. Like, is this validator community a full-fledged, like, decentralized, like, is that part of it very decentralized, or do you have any sort of, like, smaller groups that are kind of born out of that?
No. So Anoma is a full base layer. It's a layer one. There is a validator set of probably 100 or more people that runs a decentralized protocol, the Anoma protocol. They may also run matchmakers and order book operators at the same time. But yeah, it's a fundamental base layer running a proof of stake system in order to provide a private digital asset agnostic cash and end party bartering to anyone that wants to use it.
Got it. The reason I'm kind of asking is I recently completed a spontaneous series of L2 episodes. And I recently was thinking who isn't an L2? So I was wondering if you maybe would eventually sort of, alter this validation to not just be a validator on a base chain, but also some sort of connection point.
Yeah. I mean, I have fairly strong opinions on L2s and how they make the thing is pretty much everything is these things will just be connected to each other. Currently, we live in this world where everyone is trying to build their own walled garden, right? The Cosmos people are trying to build their own walled garden. The Ethereum people are trying to build their own walled garden. The Polkadot people are trying to do exactly the same. And everyone says interoperability, yes, but only within my walled garden. And it's sort of like AOL in the early days of the internet saying, my interoperability is by far the best in my own walled garden. And I think this makes absolutely no sense long term. Long term, you're just going to have probably thousands, if not hundreds of thousands of blockchains that all just freely communicate with each other because they're all going to be built around modern fast finality BFT. And then the distinction between what is an L2 and what is a L1 that just can connect to other things is becoming very thin, really.
Very blurred. Totally.
So my opinion, L2s are taking all the disadvantages of building on top of an existing system. So you're inheriting a lot of the engineering deficits. But in terms of usability, you're gaining very little over just being an interoperable L1. So I think that over time, a lot of things will become just independent L1s.
I feel like there is more and more, there's this question of we know that L2s and other L1s bridge to other L1s are actually different. And they do offer different pricing, they offer different capabilities, but they're kind of trying to solve similar problems. So it's not completely clear yet if one of these models is necessarily going to win.
I think the main thing is that people really think at the moment that you either win or you lose. But I think the general pie that we're looking at is way larger than most people can imagine. And it's not going to be, does Ethereum win against Bitcoin? It's going to be, well, we can all coexist because we all have unique offerings. And on the L2 side, to me in L2, the main thing is that you're deriving security from some L1. So you don't have your own security. And early on, people always assumed that no one was going to be willing to move their ETH, for example, into a different L1 because all of a sudden you have a totally different security model. But I think that most people really don't care because most L1s just have very good security. So the advantages to being an L2 that's tied into having to put up state roots in Ethereum, there are a lot of disadvantages because engineering freedom just goes down by a lot. And I'm not sure that the user base will care because from a UX perspective, whether you move into an L2 on top of Ethereum or into a different L1 is going to be the same. You're going to go via some bridge.
I want to go back to privacy. And we did already talk a little bit about using sapling, that a lot of this stuff would be private. But I kind of want to revisit, now that we understand a little bit more how the bartering system works and all of that, how does the privacy actually work? Is it just, this is all happening in a shielded way? Or is there parts that are very private and parts that are not? I know this has always been a question about when you're doing sort of asset transferring, you may not be able to have perfect privacy on every level. So I'm curious about where is the privacy exactly?
Yeah, so it depends on which validity predicate account you're using, right? The multi-asset shield pool is just one of many validity predicates that can exist in Anoma.
Okay.
So with the multi-asset shield pool, you're gaining pretty much perfect transfer privacy or mixing privacy, whichever way you want to look at this. But for example, for trading, we are currently writing private trading circuits as well, where maybe some of the information is hidden, but others is public, which you need in order to discover counterparties. Over time, people can deploy more and more different validity predicates that have different privacy guarantees maybe, or that may not even be privacy preserving because they want to solve some other thing that they want to have an automatic market maker as a validity predicate. This works too. You don't have to have privacy. These are just validity predicates that users get to interact with. Of course, we have an intent gossip system where people say, well, I'd like to, for example, trade a Bitcoin for an ETH, for example. And there the question becomes, how much are people revealing before that trade gets settled? And I think, honestly, over the long run, the way this will work is that most trades happen physically, like most actual commerce happens physically. And so the way you do it is that you don't announce to the world that you're willing to that I'm willing to buy like a Bitcoin from you, but rather that we communicate and agree on prices automatically, but over a local network connection, and then just end up settling it. And at that point, you can just fully privately settle this even. So you start having private subnets effectively where you may not announce all your intents, or maybe only as you advance further in the automatic negotiation, do you start revealing more and more information, but not to everyone, just at a point-to-point level at that point.
Is that kind of like a private OTC then? That's what that sounds like a little bit.
I guess you could look at it this way. That's a fair point.
But so you use this term validity predicate, and then you say one example of a validity predicate is the bartering, like basically the multi-asset shielded. So you sort of mentioned another validity predicate would be like an AMM construction, or a more like maybe an order book based DEX or something like this. Or maybe fix that then. What is, because like I think just the terminology of that isn't completely clear to me, like what goes under that category.
Yeah, so a validity predicate is every account in the system is associated with a validity predicate. So for example, when you hold like the native asset XAN on Anoma, you hold it in an account, and your account has a validity predicate attached to it. And this validity predicate in its very simplest form may say you need to have spent authorization from a private key in order to move this. But then you can also start upgrading them and say, well, if I move under $100, then I can sort of sign this with this key. And if I want to move $1 million, I need to sign with 3 different keys.
But these are not the snarks, right? These are not like the snark is with it, the proof.
No, exactly. So the verifier, for example, you could also say that you wanted to have some, like your validity predicate should only accept a specific proof. And then what you deploy as your own validity predicate is a verifier for that proof. This is the way the multi-asset shield pool is implemented. The verifier for the proofs of the multi-asset shield pool is deployed as an account on Anoma. And so whenever you want to like send an asset via the multi-asset shield pool, you submit a proof to that validity predicate, to that account, which then verifies it and says yes or no. Which means there can be many multi-asset shield pools, for example, and we can like seamlessly upgrade them as well, because you can have like multi-asset shield pool 2, multi-asset shield pool 3 as separate validity predicates in the system.
In that case, though, could you have a validity predicate model where there is no privacy using Anoma?
Absolutely.
So it's not forced. The privacy is more like in the example, in this first validity predicate that you're working on. That's one of the key things.
Exactly. Yeah.
Got it.
For example, also, maybe this is more clear, like the way Bitcoin is bridged into Anoma is that, Bitcoin is hard because it's not an efficient light client. But let's say Polkadot is bridged into Anoma because they have an efficient light client. The DOT token is just its own validity predicate, its own account in the system. And the DOT account in the system has a validity predicate that can verify a light client proof from Polkadot, and verifies whenever you want to send like a dot between 2 accounts in Anoma that like the supply is preserved, for example.
Got it. Is there anywhere else where you are working or including privacy in the Anoma stack?
So yes, albeit maybe not necessarily long-term privacy, but at least short-term privacy, which you need for front-running prevention. So we're also building a protocol called Ferveo, which is a distributed key generation protocol, which effectively means that the validator set of Anoma jointly constructs a public key, and every validator locally has a key share that they can use to decrypt with their shard. And once you combine enough decryption shares, you get the end result, which is a decrypted transaction. So when you submit a transaction on other systems, what happens is that you're giving up information. Like a block proposer or someone watching the mempool has an asymmetric information advantage over you. Because, for example, you may have said, I'm willing to trade this asset. This is now public before it gets included in a block, right? Before it's finalized in a block. Mm-hmm. So what happens in Anoma is that users encrypt transactions against this common shared public key of the validator set. And then in blocks only order encrypted transactions. So as a validator, as a block proposer, I see a bunch of encrypted transactions and I go like, well, they all can pay for the fees. Let me put them into a block. And then they're in a block, but I have no idea what these transactions do. And then in the next block, in block n+1, the validator set jointly decrypts all those encrypted transactions, and then they get executed. meaning that no one can front run you.
But they're already queued up, I guess. Like the queuing part, the part where you're putting them towards being in the block, it's unclear what's in it. Therefore, you can't have this minor extractable value MEV flash bots scenario where miners are basically getting in front of it.
Yeah. By the time you see what a transaction does, it's already ordered and you can't retroactively change the ordering anymore or inject like your own transactions.
But like I'm thinking of it like a queue, but maybe it's not exactly like that. Is it like at what stage is the actual stuff encrypted before it's decryption? Like at what stage does it get included? Like is it still encrypted when it gets included, or is it like at the moment of inclusion? This is what I'm trying to figure out.
Think about this way, right? So there's a validator set, the Anoma Network. A shared public key is known because a validator set generates them every 24 hours or so. So as a user, I want to send a transaction. Not even an intent. I just directly want to move some tokens from account A to account B. I, as a user, I construct this transaction and I encrypt it against the public key before I submit this to any full node. And then I submit an encrypted transaction to a full node, which puts it in the mempool, which only says, well, this thing can pay fees right now because that information is still available. But it doesn't see at all what the transaction does.
Got it.
Then let's say we're at block 10 right now. So this is in the mempool. The block proposer for block 10 goes, well, I have a bunch of encrypted transactions here, and let me just put them all in a block. Then the validator set comes to agreement, so reaches BFT agreement on it, and says, well, block 10 is now finalized, and it includes these encrypted transactions. And then as soon as this is in a block, validators that follow the protocol rules have to start submitting decryption shares for these transactions to each other. And then in block n+1, the next block proposer will include all the decryption shares, or not in decryption shares. They will just like use all the decryption shares and include the decrypted transactions, but not for ordering, but rather for execution.
Like, isn't NuCypher's whole thing distributed key generation? I feel like it is, but I don't know if it's ever been used in this context.
It's different. So NuCypher, I think, allows you to generate keys that are held by multiple parties, but more with the use case of being able to hold like a Bitcoin key that's shared between a lot of parties. With Ferveo in Anoma, this isn't that model. It's because the purpose is that the decryption thresholds follow the BFT thresholds, right? You need 2/3 honest majority for BFT, and you have the same requirement for the decryption part, which means that not any individual validator can like front run the system.
But it does sound a lot like the work that I know Dev and Sunny are doing at Osmosis. Are you working
we're working with
connection point?
We're working with ZK on the protocol, yeah.
The reason I say it, like, actually pretty recently we did an event with the Cosmos ecosystem highlighting some of the privacy related projects that are there. I'll add a link to also their, like, to Dev's talk there, because there's some visuals that kind of illustrate some of this as well. At what stage is this? Like, is this a protocol on paper? Is this
this is fully implemented.
Cool. Okay. So this is already like, this is something that like you have seen engineered and like this is actually working.
Yeah, this is like not theoretical. Cool. This may work in 5 years. This is like, no, this works right now and this just needs to get into a base layer. The problem is this is almost impossible to retrofit into existing base layers because it fundamentally changes the way execution flow works.
Yeah.
Which is also one of the other reasons why with Anoma, like it was never really an option, even if I had liked other ecosystems, like build this on top of another layer one, because fundamentally the way we structure transaction execution, transaction submission, all the gossiping part, it's not retrofittable into existing base layers. It's like fundamentally a different architectural choice that allows us to build very different applications.
But couldn't like an existing POS system do like a major upgrade where they incorporate something like this?
Of course. Every POS system can become any other POS system. There's nothing stopping us.
True.
Because this is all open source.
Although validators might not love it and all of the tooling might not work.
It's like the same way, like, yes, Google can become Facebook. That is true. Like the technology isn't rocket science.
Got it.
But most people don't do it because you have to maintain legacy and like your community may not like it that much.
Is there any work like this being done for proof of work systems? Because we're thinking of this as like validators building this.
So this doesn't work for proof of work because fundamentally in proof of work, you don't know who the miners are. Like upfront, like in proof of stake, we have a list of these are all the public keys that are the validators. And we need this because every validator needs to generate private key shards.
Yes. This is a very proof of stake solution.
This is also like why proof of work, I think, will exist for like very simple applications for a long time. Because it's interesting. I think Bitcoin is cool in the sense that we have like a global stable clock, for example, that's hard to bias. But like the innovations are going to come in proof of stake because the protocols are more flexible. So one thing about Ferveo is it also provides really secure randomness in the sense that it doesn't require VDFs with like special hardware to produce unbiasable randomness. But out of running this distributed key generation protocol, you also get secure randomness, which you currently aren't using in just the way that it works in the cryptographic protocol. Just also gives you this.
Cool.
So like we don't currently have I don't have an application in mind yet to build on Anoma that uses this, but it is available.
Nice. That's very useful. I wonder if you could use that back into something that's like at the core.
Yeah. I mean, other consensus algorithms like use randomness to select validators. I'm not a big fan of it.
Okay. So it won't be that.
Maybe like later on you can use this also in like the proof of stake system and the consensus mechanism.
I know that at some point in the last half hour or so, you mentioned intent gossip. I kind of want to bring that back up and talk about that in this context of like the bartering system and all of these like multiple pools. Because gossip, as we've understood, is sort of like message passing, right? It's sending a message out and having it be repeated. But how does it work in this system? Is it different?
Yes. Well, okay, let me explain sort of the way the intent gossip system works. So it's a matchmaking system. So in Anoma, people can't just only submit transactions that directly hit the chain, but they can also submit intents, things that they need to coordinate with other people effectively. This may be a trade or an agreement to like try to fight climate change, to like incorporate cost of carbon. It's arbitrary what they can do, what intents people can submit. And the way these intents work is that they float around in a gossip system for these intents before they get settled on chain. And then people look at them, and there's incentive there for people to match different intents that can be that are matchable with each other. Mm-hmm. This also comes in really handy though, given the upgrade system that Anoma uses. So Anoma upgrades fractally, so it scales fractally and it upgrades fractally, meaning that we don't have these binary switchovers that all existing systems have, and that really suck in my opinion, because in a binary upgrade system, your software either like today, the new software comes active and controls 100 million, but you have no testing outside of like test environments. But there was no like slow ramping up of value being tested on the new protocol version, right? With Anoma, the way Anoma upgrades is that you deploy a new protocol version. Anyone can deploy a new protocol version. And over time, assets can slowly migrate into the new version, right? Because Fractal instances are interoperable with each other. So from the main ledger, you launch prototype 2, slowly assets migrate. If a lot of assets migrate, then you can do the final binary switchover where you migrate all the remaining state with you, right? So this is how Anoma upgrades, but the intent gossip system works globally over all instances.
Even if it's previous versions?
Even if it's previous or future versions.
Does that mean like trades can actually happen across that as well?
Yes, trades can also happen between Fractal instances, which means you have like liquidity between, because otherwise you have the problem that like your liquidity is fundamentally tied to your Fractal instance. So the upgrades almost always have to be binary in that case. But in Anoma, you aren't forced into this. You just get one global gossip layer for all instances.
I think I forgot to ask this, but like we talked a little bit about the like clients, but are all of the instances running like clients? Is that how you'd kind of imagine it, or?
Yes.
Okay.
Like they connect to each other via currently most likely IBC, because it's honestly like an asset agnostic protocol that just works well. But honestly, I'm struggling with this a little bit I think the way people currently think about these systems is like, oh, interoperability protocols are specifically tied to existing things. And that's like entirely not the point of interoperability protocols. That are like meant to neutrally connect things. So Anoma will support whatever interoperability protocols come out. If there are better protocols like UDP, for example, a different protocol from the internet stack, if that comes out in 2 years, Anoma is happy to support it because we just care about using well-designed, well-specified interoperability protocols. And yeah, so fractal instances also connect via the same interoperability protocols.
Can fractal instances also be different types of blockchains? Like, could there be a UTXO one, an account model one? Is there like variations on these, or do they have to have at least some baseline consistency?
So the Anoma protocol can probably change quite fundamentally, but I don't think it could change to UTXO or a different account model, because a lot of the transaction execution flow and the way privacy works is just tied to this account model, like to this very generalized account model. Also, I don't see a reason why you would want to do this. Okay. UTXO seems clearly worse. Same for like the existing account models with imperative execution.
Okay, so let's talk then about different types of account models. And is Anoma built like Ethereum, first off?
There are accounts, let's say it this way.
Okay.
But like something like Nia or even Polkadot is much closer to Ethereum than Anoma is. All these systems have accounts. And like, for example, the way smart contracts on Nia work is also, it's like this imperative execution, right? Like you invoke a smart contract, you invoke an account with code in Nia, and it sort of starts with the first instruction, goes to a second, goes to a third. Maybe it tries to call a smart contract. Maybe this is a synchronous or asynchronous call, but it's fundamentally top to bottom. What happens in Anoma is more that the state changes are computed first, and then they're passed into all validity predicates at the same time. And these validity predicates really don't do computation in that sense. They do verification, whether they are happy with the state changes. So they sort of go, they don't go, let me call next contract, let me then do 5 + 5. They go, this is the resulting state. Am I happy with this? Like, am I happy that I lost a Bitcoin and received 10 ETH? That's sort of the model.
And there's this validity predicate that's submitted alongside each. Is it in each account, or is it in?
Every account has a validity predicate.
Okay. Is that submitted, or is that the verification side of things? That's what's used for verification.
So when someone creates an account, like when an account is created, a validity predicate has to be attached to that account. And then that validity predicate can do verification, like is invoked when that account is invoked as well.
How does the Ethereum one work then? That one's more like writing.
So in Ethereum, I call an account, and then you also invoke the smart contract, the code in the account, right? But the code more goes like, it doesn't see the resulting state. It just tries to like do 5 + 5, call a separate contract, move a token somewhere. Like it does imperative computation. Whereas in Anoma, it's more of a functional system to some extent. Like you can think of this kind of like Ethereum is imperative and Anoma is more functional in terms of how the accounts work.
So at what stage is the Anoma project today? Are we talking it's on testnet? It's still like modules that are kind of like being put together? Is it incentivized? Like where are we at?
Yeah, so maybe one important note here to start off with is Anoma is pretty far along. This is like not a researchy kind of idea where we're trying to figure out whether this works in practice or not. All the research is done and it works, and it's mostly focused on implementation at this point. So we are currently running the first internal testnets. Hopefully we're starting to have public testnets in the next 4 weeks or so. It's like the first public testnets. And then probably incentivized testnets later this year as the stack gets more and more testing. This is where we are timing-wise.
What do you imagine, like maybe it's too early to say this, but do you imagine sort of a first use case that you're going to highlight or work towards?
Yeah, I think one of the first use cases is certainly going to be this multi-asset chill pool and just giving people incredibly good privacy guarantees, irrespective of what asset they hold. I think really people underestimate this. This is currently completely impossible to do in our space. Like if you have a CryptoKitty and you want to shield your CryptoKitty, that just doesn't work. It's impossible. With Anoma, your CryptoKitty can live in exactly the same privacy set as like your USDT coffee payments. So I think that's absolutely going to be one of the first use cases, providing people really, really good privacy, no matter what the assets they hold. And then later use cases, I can see a number of things appearing, whether this is around trading, around AMMs, around private bartering a lot. I think just being able to write more validity predicates at more private circuits.
I have one little, I'm going to take one step back for 1 sec, because the CryptoKitty example just made me think of a question. If it's an Ethereum-based CryptoKitty, does it get locked somehow in Ethereum in order to enter Anoma, or? Is that kind of how it would work?
Yeah, I mean, this is how bridges work generally, right? That the way you move an asset across a bridge is that you lock it against the validator set of the receiving side. They then mint it for you. And then the nice thing is if anyone else wants to go back, they can also, and the validator set, you burn it on the Anoma side and the validator set unlocks it on the Ethereum side. I think at some point we should do like a whole episode around how bridging tech works.
For sure. That is actually so on the docket. Like bridging as a topic has come up so often over the last little while.
I can give you a sneak peek there.
Yeah.
I don't think bridging makes a lot of money.
Ooh, how do you know that?
Because like bridging Anoma to Near, it's like there's no work involved. It's like you just send a bunch of data that exists on both chains to each other. Like no one is going to charge a 1% fee to move an asset from Anoma to Near. For legacy chains, this may be different. So like for Bitcoin, ETH, Monero, Zcash.
NFTs maybe?
Depends where the NFTs live. So if the NFTs live on Ethereum, maybe.
Yeah.
But if they live on Near, like moving data between Near and Anoma is trivial.
Whoa. Okay, yeah, this is a topic. We're at the end of the episode, so we won't be able to cover it this time, but it is coming. This is really, it's good to highlight it now. Cool. Okay, so listen, Adrian, thank you so much for coming on the show and sharing all of this work and thinking around Anoma and the project. Can people already get involved, learn about it, go somewhere? Where should they go?
Yeah, absolutely. So Anoma Network is the first place to stop. We have the research blog up there, so a lot of the underlying tech is explained in it, and we're releasing more and more explanations for how all the stack works. There's the white paper as well, which explains Anoma in a very comprehensive way. I'm a big fan. It's not that long. It's like 8 pages.
Yeah. It's a bit longer than that. I think it was 14 pages. I recently looked at it.
maybe 14.
Anyway.
Don't tell them. Get the book first. And yeah, so we're always looking for good engineers. If you're interested in privacy, bring privacy to the masses, bring privacy to all assets. Reach out to me. You can reach me at Adrian at Anoma.network. You can also find us on Twitter under Anoma Network. Yeah, and I mean, public testings are coming. So Join the Discord. They're going to come in the next 4 weeks or so. So looking forward to it.
Very cool. So thanks again, Adrian, for coming on the show.
Thank you for having me.
I also want to say thank you to the podcast producer, Andre, the podcast editor, Henrik, and to our listeners. Thanks for listening.